Yeah. Hi guys. Thanks for joining the session and a very good morning everyone. And today we are going to learn about packet flow inside the firewall. Okay. Inside the firewall, since once the traffic receives from your missions. Okay. Whatever the client mission that you are using. So let's take you have a Windows mission. Okay. You are browsing something on the internet, and the traffic receives the firewall. So once the traffic receives the firewall, how the firewall is going to inspect the traffic, what are the checks that are going to do in every stage. There are multiple stage once the packet receives the firewall, like ingress stage, slow path, fast path, application identification, content inspection, egress stage. Okay, all these stages has to be complete in order to packet or traffic comes out of the firewall. So if something is happen in any stage, the firewall will not send the traffic out, and firewall will drop the packet. Okay. So once traffic receives a firewall, and if the traffic has to leave the firewall, so when there is no, okay, no errors or no threats or no vulnerabilities are detected, then only the firewall send the traffic out to the internet. Otherwise, the firewall will drop. So we can okay, we can see what are the stages involved in this. Okay, and in which stage what will happen. So let me open the paint. So see here, let's have a firewall, and we'll be having one Windows machine. So this firewall is connected to the internet. Okay, so the connection will be like this. So whenever the traffic, okay, let's suppose you are browsing www.facebook.com. Okay, whenever you are browsing facebook.com, your traffic from your Windows machine or Linux machine or whatever the client that you are using, from the client machine, the traffic receives on the firewall. Okay, so at which interface the firewall receives, okay, that will be calling as ingress stage. Okay, first stage in this process is ingress stage. So the interface at which the firewall receives the traffic will be calling as ingress interface. Okay, or uh, inside interface. Okay, we'll be calling as inside interface or ingress interface, and the stage will be calling as an ingress stage. Okay, in this ingress stage, what will happen means the firewall will extract tuples. Okay, we'll be calling as tuples here. So what are those tuples means? So whenever the firewall receives a packet, the packet will be in the form of, right, L1, right, physical layer, Ethernet header, IP header, L4 which is TCP. After that you will be having data payload, right? So from these headers, what firewall is going to means, the firewall is going to extract the tuples. What those tuples means? So from L3 header, the firewall is going to extract source IP, destination IP, and protocol. Okay, so these are the three fields that the firewall is going to extract from L3 header, and from L4 header it is going to extract source port, destination port. Okay, so why it is going to extract means we'll discuss this, okay, in the next stage. So these are the things that the firewall is going to extract. Okay, and also the firewall receives the traffic on this particular interface, right, which is called ingress interface or inside interface. So from this interface it will also extract the zone. Okay, so we are configuring the zones, right? So yesterday we have discussed about zones. Okay, why we are configuring the zones here? Anyone? Yesterday we have discussed about the zones, right? So what is the purpose of zones? Why we are using zones in firewalls?
Separating the traffic.
Separating the traffic. Okay, Any other answers?
To minimize the area of attack.
Yeah, okay. Any others? Any other answers, guys? Yeah, whatever you said, to separate the traffic or to protect from the attacks, that's all correct. Any other answers?
To write the policies and
Uh,
destination to write source code.
okay, that to write the policy that in order to communicate between the zones, we write the policies. But I'm asking why we are creating a zones.
for like a security boundaries and
Yeah, that's correct. Okay, in order to protect our private network from the public network, we are segmenting the zones. Okay, so let's consider this is our inside zone and this is our outside zone. Okay, so the firewall which is okay, the interface which are connected internal to our private network will be calling as inside zone, and the interfaces or the devices that are connected outside of our network will be calling as an outside zone. Okay, and from here, so this interface is connected in the inside zone, right? So from this interface it is going to extract the source zone. We will be calling this as a source zone. So here it will be going to extract the source zone as well. Okay, so from ingress stage, all these six tuples will be calling these as tuples. So from ingress stage it is going to extract all these tuples. Okay, six tuples. And next, after extracting these six tuples, the firewall is going to verify if there are any ingress errors. Okay, so from L2 will be having some data checksums, right? In the L2 header we'll be having checksum, and L3 header will be having data checksums. From those checksums, the firewall is going to verify if there are any errors in these headers. Okay, if there are any errors available or if there are any ingress errors identified, ingress errors identified. So what the firewall will do means the firewall will drop the packet. It won't proceed. Okay, the firewall drop the packet here. So it will not proceed further if there are any ingress errors identified from all these headers. Okay, and if there is no ingress errors, the firewall will proceed with the next step. Okay, so here, this is the ingress stage where the firewall will extract the tuples. What are those tuples means? Source IP, destination IP, source port, destination port, protocols, and source zone. These are the six tuples that firewall is going to extract from the firewall, extract from the ingress stage, which are which are extracting from all the headers. And after extracting that, it is going to verify if there are ingress errors. Okay, if any ingress errors are identified, the firewall will drop the packet, or otherwise it will proceed further. Okay, and okay, this is the normal traffic. Okay, this is normal traffic. If any tunnels are configured between your client and the firewall, okay, if any tunnels or VPNs are configured, tunnel or VPN configured. So if tunnel or VPN configured, the traffic will be in the form of encrypted, right? So encrypted in sense, whatever the tunnels we are forming, the traffic will be coming in the form of encryption. So what firewall need to do in order to inspect the traffic? The firewall has to be decrypted, right? So whenever the traffic receives from the client or any of the Windows machine or Linux or Mac OS machine, if that is a tunnel traffic, the firewall will decrypt the traffic. First, the firewall will decrypt the traffic, and then it will extract the tuples. Okay, so how it is done here in this case, so it will extract all those six tuples, and again it will be going for the ingress error side. Okay, if it is going to verify the ingress errors. Okay, so this is a simple. Okay, if the normal traffic, it will be not in the form of encrypted, so the firewall directly extract. But if there is any tunnel configured or VPN configured, so the traffic will be in the form of encryption. So in order to extract the tuples, the firewall first decrypt the traffic and then extract all the 6 tuples. And once it is extracted, so it is going to identify, it is going to verify the ingress errors. And after extracting the tuples and after verifying the ingress errors, it is moving into the next stage, which is an slow path. We'll be calling as a slow path. So guys, please remember this terminology. This is, I think, this is new for you, but these are the terminologies we are going to use in the Palo Alto firewall, but you have to remember these terminologies. So ingress stage, first is an ingress stage, second is a slow path. So slow path is mainly for whenever firewall receives a new traffic. When the firewall receives a new traffic, new traffic in the sense, you are initiating the traffic newly. There is no previous traffic for the Facebook. Now you are initiating the new traffic for the Facebook. You are the first, or you are accessing the Facebook for the first time, or you are accessing the Facebook newly on your Windows machine, so that we don't have any entries on the firewall, so that will be considered as a new traffic. And the firewall will be moving into the slow path for that case. So how the firewall will be identified whether it is a new traffic or old traffic means, the firewall will be maintaining the flow table or session table. Flow table or session table. Yesterday we have discussed about monitoring and logging, right? The firewall will support monitoring and logging. So what is the purpose of logging? So the firewall will log the sessions for that particular traffic. So in that flow table or session table, what will be having means, it will be having flows from client to server and server to client. So these flows will contains what these flows actually contains means, it will contain source IP, okay, destination IP, source port, whatever destination port. Okay, and it will contain protocol, and it will contain source zone. Okay, and it will contain type, session type. Okay, we'll discuss about session types later in this session. Okay, so this flow table or session table contains all this information. And here also in the client, server to the client flows also contains all this information. Okay, so if it is a new traffic, the firewall will not having the flow table or logs in a flow table or session table. Okay, so if it is a new, if it is an old traffic, the firewall contains an this information in flow and session table, and it is not moving to the slow path. Okay, so now we are accessing the Facebook for the first time, right? So what, let's suppose we will be having an source IP like 10.10.10.1, and destination IP which is our Facebook server IP, right? So let's suppose you will be having Facebook server IP here. Okay, whatever it may be, the destination will be the Facebook server IP. So whenever this traffic reaches on the firewall, it is already extracted all these tuples, right? So it extracted all the tuples with source IP 10.10.10.1 and destination IP, okay, Facebook server IP, source port, any random source port, and destination port. It is an HTTPS traffic, right? So what is the port number of HTTPS?
443.
443, right? So here the destination port will be 443. Okay, and protocol, you can see whatever the protocol, whether it is an HTTPS, right? So it will be an TCP, and protocol number will be 6, and source zone will be this inside. Okay, so it will extract all these tuples, right? So once it is extracted all these tuples, it will be verify if any flows is matching with these tuples in the flow table. So then only the firewall is going to identify whether it is a new traffic or old traffic. So if there is no session, or if there is no flows available in the session table for the tuples we have extracted, సో ఇక్కడ మనం ఏదైతే టపుల్స్ ఎక్స్ట్రాక్ట్ చేశామో ఆ టపుల్స్కి మనకి ఫ్లో టేబుల్లో ఓకే మనకి ఫ్లోస్ లేవనుకో అది న్యూ ట్రాఫిక్. సో whatever the tuples that we have extracted, if you see any flows in the session table, that is a old traffic. Okay, so this is a new traffic, so we cannot identify. Okay, the firewall will not identify these flows in the session table, so that's where it will be identifying a new traffic. So if it is a new traffic, that firewall will be moving into the slow path stage. Okay, so what exactly happened in the slow path stage means the firewall will first do an forwarding lookup. Okay, so forwarding lookup or route lookup we'll be calling as an route lookup as well. So what is forwarding lookup and what is route lookup means, so this is how okay the firewall is going to identify to which to where it has to be send the traffic. Okay, just same like how the routers will do route lookup, the firewall will also do an route lookup here. So to which IP it is going to do a route lookup for the destination IP. So we have extracted the destination IP, right? So here in this case the Facebook server IP. So in order to send the traffic out, the firewall should have the route to the Facebook server. So it is going to identify if there is route in the routing table or not. Okay, for the destination IP that we have extracted, for destination IP, the firewall will do the route lookup. Okay, so in this route lookup, so it is going to identify the what is the route to the destination and also the exit interface. Okay, it is also going to identify exit interface. Okay, which is this interface, the firewall's interface which is connected to the public. Okay, and from here, from the forwarding lookup, apart from doing an route, okay, identifying the route to the destination, so it will also going to extract the destination zone. Okay, so which is okay, the destination zone which we have configured, which this exit interface lies. Okay, so this exit interface lies in the outside zone, right? From here it is going to, so it is going to extract the destination zone. Okay, we have already extracted source zone here in the ingress stage, and in the slow path we are going to extract the firewall is going to extract the destination zone from the exit interface. So from the route table it is going to find the route to the destination and also the exit interface. For this exit interface, so it will be going to extract the destination zone. So now we have 6 tuples plus 1 tuple. Okay, we now we will be having 7 tuples. Okay, so now we will be having 7 tuples. So with these 7 tuples it is going to identify okay any policy lookup. In the policy lookup it is going to identify. Okay, we'll discuss that in the policy lookup. So after identifying the route, okay, if the route is exist, it is going for the next process. And for the destination IP, okay, whatever the destination IP that we have extracted here, if the route is not there in the forwarding table or route table. Okay, there are two types of tables, right? Route table, one is a route table and other one is a forwarding table. In the firewall you can see the two tables. Okay, so if the route to the destination IP is not there in the forwarding table or route table, the firewall will drop the traffic here. Okay, the firewall will not proceed. So if there is no route, the firewall don't know, right, how to send the traffic out, or how to which to where the firewall has to send the traffic, what is the next stop, what is exit interface, the firewall don't know if there is no route in the routing table. So the firewall will drop the traffic here. If there is a route in the routing table, then only the firewall will proceed further. Okay, so after forwarding lookup, what will happen means the NAT lookup will happen. Okay, so we have discussed about NAT in the okay last weekend, right? So I think you people are joined so in the NAT class, right? So here in this case, in the firewalls, we are going to configure a NAT based on the flows. Okay, so in this based upon the flows, how many NATs we will be having? Anyone? So we have discussed in the NAT class, right?
Three,
No,
three,
no,
sir.
I'm asking about based upon the flows, how many nets? Okay, whenever we are sending traffic from inside to outside, which NAT we are doing, and whenever traffic coming from outside to inside, what which NAT we are doing? So you mentioned, someone mentioned about three, right? So what are those three?
Static, dynamic, pat.
Yeah, static, dynamic, and pat. And I've also discussed about two more nets based upon the based upon the traffic
Source
flow.
net, destination net.
Yeah, source net,
Source net.
destination net. Yes, that's correct. So see here, the firewall will do two types of nets here. Okay, one is a source net, one is a destination net. Okay, so whenever the traffic flowing from inside to outside, the firewall will do a source net. So in the source net, what it will do means, so our source IP translated to public IP, and it will proceed further. Okay, in the source net, it will just translate the our source IP to the public IP, and it will proceed further. Okay, but whenever traffic coming from outside, okay, so let's suppose we are getting getting a traffic from our internet to inside. What firewall will do means, firewall will do a destination net. Okay, right? So here in this case, what will happen, the destination IP will be translated here, right? Destination IP will be translated. Okay, so destination IP will be translated in sense our destination IP is going to change here. Okay, so whenever the traffic comes from outside, the firewall receives the traffic, and at that particular interface, so the firewall is going to change the destination IP, right? So if the destination IP is get changed, the firewall again do an forwarding lookup. Okay, if the destination IP is changed, the firewall will do the forwarding lookup again. Okay, so why we are doing forwarding lookup again means, the destination IP got changed, right? So for the destination IP, for the change of destination IP, here we are translated the destination IP, means the destination IP got changed. For the translated destination IP, the firewall is going to look if there is any route in the routing table or not, right? So if there is a route in the routing table, they will be okay identifying the what is the exit interface and what is the next stop, and where it is has to be sent. So that is the reason. So if the destination is not happen, the destination IP is going to change, and for that translated destination IP, the firewall will do an forwarding lookup again and will identify what is exit interface and what is the next stop, and it will send the traffic. If there is no route, or if there is no route in the forwarding lookup, okay, so the firewall will drop the traffic here as well. Okay, if there is no route in the routing table for this destination IP, translated destination IP, the firewall will drop the traffic here. If there is a route in the routing table, then only it will be proceed further. Okay, so it will be proceed. Let's suppose we have okay route in the routing table for this destination IP, and it is proceeding further. So the law, okay, this is policy lookup. So this is where the policy lookup will be done by the firewall. So in the policy lookup, so it is going to verify the policy for all the 7 tuples that we have extracted. Okay, so what are the 7 tuples? Can anyone mention here? Anyone? So we have extracted the 7 tuples, right? So here 6 and here 1. Can anyone mention all the 7 tuples? Can anyone list all the 7 tuples here?
Source IP,
Source IP,
uh, source port,
source port,
a protocol,
protocol,
type,
type,
destination IP,
destination IP,
destination port,
destination port,
source zone,
source zone,
destination zone.
yeah, destination zone. Okay, these are all the tuples that we have extracted, right? For these tuples, it is going to match if there is any policy configured or not. Okay, so in order to route the traffic from our firewall from one zone to another zone, we are configuring a policy. Let's suppose I have configured a test policy. Okay, test policy, and I have included source IP, okay, as 10.10.10.1, and so destination IP, which is our Facebook server IP. Okay, I mentioned source zone as inside, and destination zone as outside. Okay, and I have configured okay, protocol, not protocol, I will be configuring some service which is HTTPS. Okay, so I configure like this, I configured a policy like this. Okay, so whenever my traffic hit the firewall, it will be okay, after all doing this, it will be going to verify the policy lookup, and in the policy it will be verify whether any policy is matching for my tuples. Okay, so what is our source IP here? So what is our source IP? 10.10.10.1, right? So if this policy contains source IP as 10.10.1, okay, we have configured policy with source IP 10.1, it is matching. What is our destination IP? So destination IP is Facebook server IP, right? So here also we have configured destination IP as Facebook server IP, it is matching. So what is the source zone here? Source zone is inside zone. Okay, this is our inside zone, and the source zone is also matching. And what is the destination zone? So destination zone is outside. And what type of service we are using? HTTPS. Okay, so it is matching with our traffic, so it is hitting this policy, and it is checking, it is going to verify the action. Okay, so it is going to verify the action. Under the actions, we will be having multiple actions in the security policy. One is an allow, okay, and other one is an deny, and again drop, and we are using mostly these three. And apart from this, we will be having reset client. Okay, and next one reset server, and next we will be having reset both. Okay, we will be having like this actions. Okay, so whenever you configured action as an allow, so for this matched policy, whenever you configure action as allow, the firewall will allow the traffic. Okay, the firewall will allow the traffic towards our Facebook server. And if you configure deny and drop, so the firewall is going to block. Okay, the firewall is going to block the traffic here, or the firewall is going to block the packet here, and it is not going to send the traffic out. Okay, and here we are, I am using a two terms. Okay, deny and drop. Okay, both will be blocking the traffic, but there will be a slight difference between the deny and drop. Can anyone know about deny and drop? What is the basic difference between deny and drop? Here in the firewall, both will be using to block the session or to block the traffic, but there is a slight difference between deny and drop. Can anyone know basic difference between deny and drop? Anyone? Yes or no?
Denying which means particularly we don't allow the
Mm-hmm.
particular traffic.
Okay.
We
And drop?
denying. Yeah.
Drop?
Drop which means if something is there any mistake in the it mean exactly I don't know, but I
Mm-hmm.
mean that
Yeah, yeah,
drop
go
is
ahead.
something. Drop is something in the traffic.
Okay.
In
But
deny, there will be reply sent to the user like you're blocked or you're denied accessing the server. But in the drop, there will be one-way direction and the drop of packets will occur there.
yes, that's correct. Yeah. See here, whenever you are configuring action as deny, so along, okay, the firewall will block the traffic, and it is going to send an error message to the source. Okay, which is our source means which is our client. Okay, so the firewall will block the traffic, and it will also send an error message, ICMP error message to the source whenever you configured action as a deny. Okay, and when you configured action as a drop, the firewall will simply block the session and drop the packet here. It will not sending any error message to the source. Okay, whenever you configured action as a drop. Okay, this is a basic difference between deny and drop. So I have encountered this question whenever I'm giving interview. Okay, to for the, okay, one of the firewall. So they ask this question. Okay, so in the security policy you have an, okay, deny and drop, both will be blocking the traffic, but what is the basic difference between them? So this is a difference. Okay, whenever you are using deny, so it will block the traffic, along with that it will send an error message to the source, but drop will simply block the traffic. It is not going to send any error message. Okay, that is the basic difference. You have to remember this. So whenever you are configuring policies in the tomorrow lab, you can see all these things. Okay, allow, deny, drop, reset client, reset server, and reset both. Okay, what is reset client means? So if something traffic wants to be reset from the client, so you can send, okay, you can configure action as reset. And if something traffic you want to, okay, reset from server, you can configure this. And if the traffic want reset from both, you can use. But these three we are not using anymore here in the Palo Alto firewall. Okay, mostly you can use allow, deny, or drop. Okay, so just know, okay, basic difference between deny and drop. And also allow means it will be allowing the traffic, it will not do anything, it will just allow the traffic based upon the action. Okay, so here in the Palo Alto firewall, the policies, okay, policies will work from top to bottom approach. Okay, policies will work from top to bottom. Okay, so what is this top to bottom approach means? So you have 100 policies. Okay, we have, okay, first policy, second policy, third policy, fourth policy, fifth policy. Likewise you will be having 100 policies. Okay, and now, okay, here what we have done, so whenever traffic reaches, the firewall is going to match the policy, right? So with that, all the tuples, so what is my source IP, what is the source IP configured in the policy? So my source IP is 10.10.10.1, the source IP that I configured in policy is 10.10.1, the source IP is matching. So here in this case, my destination IP is Facebook server IP, and what is my destination IP here? Facebook server IP. It is also matching. So what is the source zone? The source zone is inside, and it is here also inside. It is matching source zone. What is my destination IP? Destination zone is outside, and destination zone here also outside. What is the service I am using? HTTPS. HTTPS is also matching. So if it is matching at the first place, so it is going to verify the action. Let's suppose I have configured this policy at 100th place. Okay, at 100th place, and all these policies are not matching. Okay, first it will be verify the first policy, source IP, it will verify source IP, it will verify destination IP, it will verify source zone, destination zone, service, everything it will verify. And if it is not matching on the first policy, it is moving to the second policy. And in the second policy also is not matching anything, it is coming, okay, to the third policy. And if the third policy is not matching, it will come to the fourth policy. If the fourth policy is not matching, it will come to the fifth policy. Likewise, the firewall will, okay, match the policies until, okay, the firewall will move forward until it matches the exact policy. So our exact policy configured at 100 place, so it will be skipping, okay, not skipping. So it will be, okay, verifying each and every policy that we have configured. Likewise it will verify 99 policies, and it is coming to the 100 policy. So in the 100 policy we have configured this, and this is matching. And now if it is matching, it will be verifying the action. And in the action, whatever the action that we have mentioned, if it is an allow, it will be allowing the traffic. If it is a denied drop, it will block the traffic otherwise. And if the 100 policy is also not matching, we will be having two default policies, which is intra-zone policy and inter-zone policy. Okay, if it is an inter-zone policy, it is going to block, or if it is an intra-zone, it is going to allow. Okay, likewise the policy lookup will be happen top to bottom approach until it matches the policy. Okay, so this is the one thing you have to verify, or this is the one thing you have to note down. Okay, so if you have configured this policy in the first place, so it will be verifying this policy, it is matching, and it is going to say check the action. It don't want other 100 policies. Okay, if you are configuring a policy in 100 place, it is going to verify each and every policy. Okay, that is the top to bottom approach. It will not going to skip any policy. It will not directly come into 100 policy. Okay, it has to be verify each and every policy until it matches. Okay, now in this case we have policy at 100 place, so it will be verifying 99 policies first, and it is coming at the 100 policy. Okay, that is the policy, okay, top to bottom approach in the Palo Alto firewall. So now if you set the action as allow, Okay, if you set the action as allow, the firewall is now going to the firewall will install the session in the session table. Okay, so before, whenever we verify the session table, we don't have this flow in the session table, right? Because this is a new traffic. Once this policy lookup done, so once the policy lookup done and you are okay allowing the traffic, the firewall will install the session in the session table. Now this session will be here, okay, in the session table. Source IP is this, destination IP is this, source port is random source port, destination port is 443, protocol whether it is an UDP or TCP it will mention here, source zone is inside or destination zone is outside. Okay, and type, what is the session type? Okay, I will discuss this in the later in this session. Okay, so it will maintain like this in the session flow session in the session table. Okay, it will also contain source to, okay, server to the client. Server to the client means reverse traffic. The source IP will be Facebook server IP, destination IP will be 10.10.10.1, source port will be now 443, destination port any random port, protocol whatever the protocol whether it is an UDP and TCP, and here the source zone will be this one. Okay, the source zone will be this and destination zone will be inside zone, and type we can see this later. Okay, likewise it will be maintaining the session in the session table, C2S flow and S2C flow. C2S flow means from client to the server like this, and S2C means server to the client. Okay, it will be installing the session in the session table like this. Once the policy lookup will be happen, and it is going to maintain the session in the session table. Okay, it will also log the session in the session table. Once it is done, so it is moving into the next stage, which is our fast path. Okay, so the fast path is mainly for the existing session. Okay, so the slow path is only for the new traffic, and fast path is only for the existing traffic. Okay, this fast path will work for the return traffic. Okay, now we send an okay, let's suppose I'm accessing www.facebook.com, right? So when I'm accessing facebook.com, it will be sending the request to the Facebook server. Now we, okay, once the traffic receives on the firewall, it will be verifying all the things, and it will be sending, okay, it will be sending the traffic out, and before sending the traffic out, it will be logging a session in the session table. And again, in the session table you can see C2S flow and S2C flow, right? And again, once the traffic receives on the firewall, this is an our request. Okay, whatever the response that you are getting from the Facebook server. So already for this traffic we are already having an existing session here. Okay, we'll be having this S2C flow. So this will be verifying this table, and if that session is existing the session table, it will be moving to the fast path. So in the fast path, what firewall will do means, again it will do an okay, it will extract, extract the tuples. Okay, and it will again do an ingress error inspection. Okay, it will again do an ingress error, and if there is any ingress errors available, because this is a return traffic, right? So the return traffic again is it has to be extract the tuples, and it has to be verify if there are any existing okay, session in the session table or not. So already we have, okay, we already send the traffic out from the firewall. The firewall has logged the session, so here it will be going to match with S2C flow. Okay, because it is for the return traffic, right? So it is going to match to the S2C flow, and it will be considered as an existing session. Okay, and for this existing session, what it is going to do is, so it is going to do a NAT again. Okay, it will be going to a NAT lookup. So in the fast path, it is going to do an destination NAT, because the traffic is coming from outside to inside, right? So here it is going to do an destination NAT. So in the destination NAT, it is going to translate destination IP, right? So destination IP will be translated, and if it destination IP got changed, again it is going to do an forwarding lookup. Okay, forwarding lookup will happen, and it is going to identify whether route is available in the route table or not. If the route is available, it is going further, and if the route is not available, the traffic will be dropped here. Okay, so after the NAT lookup, so what it will do in the it will do in the fast path means, so here in this case, so it is going to identify the application. Okay, so most probably this is an HTTPS traffic, right? So HTTPS traffic means it has to be decrypt the traffic. Okay, so whatever the traffic receives, it is in the form of HTTPS. Okay, HTTPS means the traffic whatever the application that we are using here. Okay, let's suppose www.facebook.com. Okay, so if it is www.facebook.com, we the whatever the traffic coming from client, so this application will not be this application will not be seen by anyone in the internet, because this is going to encrypt, this application is going to encrypt, we cannot know what exactly lies in this. So what firewall will do means, this traffic the firewall is going to decrypt here. Okay, so here we'll be calling as, and it will be doing an SSL decryption. So we'll learn about this SSL decryption briefly in our SSL decryption class. We have separate class for this, but just I'm just explaining very light here. Okay, so what it will do means, it will do an SSL decryption. So what exactly in the SSL decryption will happen means, it will be going to decrypt this. Okay, it is going to decrypt this traffic first. Okay, the firewall will decrypt the traffic, whatever the traffic or whatever the packet receives on the firewall, and after decryption, it is going to identify the application, what type of application it is. Okay, and after identifying the application, and it is also going to verify if there are any threats. Okay, that will do in the content inspection. I will discuss that in the later. And in the fast path, so it will do an SSL decryption, and from the SSL decryption, the firewall is going to identify the application. How it is going to identify the application means, every firewall will maintain application database. Okay, so application database, and we'll be calling as an app ID. So in this app ID, the firewall is going to identify the application using an signatures. So every application has its own signature. These signatures will be available in the app database of the firewall, and whatever the application that it has, it has identified here, it is going to match if any signatures available here in the Palo Alto firewall or not. Okay, so if any available signatures are available in the Palo Alto firewall, so it is going to identify the application. But here it has decrypted the traffic, and it has found that this is some web application. Okay, so if this application is matching any signature in the firewall, okay, the firewall is going to identify the application. Okay, then only the firewall is going to identify the application, otherwise the firewall will not identify the application, and the firewall will drop the traffic. So with this traffic, it is going to match if any signatures available in the Palo Alto application database or not. So if the signature is matching with this application, whatever the traffic that is we are sending, so it is going to identify the application. Now here in this case, it is here we are using a Facebook, right? So in this Facebook, the firewall is going to identify if any Facebook signatures are available or not. So if the signature is available, so the signature, the firewall knows that is an Facebook application signature. So if the signature is matching, the firewall is going to identify the application as Facebook application. By seeing this Facebook, we can know what type of application it is, but firewall will don't know what type of application the user is using. So how the firewall is going to identify? It is going to identify by matching the signatures. If the matching signature is available, the firewall is going to identify that with that signature, the firewall is going to identify the application is a Facebook application. Okay, once the application is identified, once the firewalls identify the application here, the firewall will then going to do an policy lookup. Okay, policy lookup again, because the firewall has to know whether this application is allowed or whether this application is blocked. Okay, so it will do an policy lookup. if the application is allowed or block. Okay, so if it is allowed, the Facebook application is going to allow, or if you configured a policy to block, the firewall is going to block the traffic. Okay, let's assume you have allowed the application, and okay, the firewall is going to allow your Facebook traffic, and it is going into the next stage, which is content inspection. Okay, so if the Facebook is identified in the fast path, okay, here, so this is the content inspection is the fifth stage. Okay, so the content inspection is the fifth stage. So but we are in the third stage. Okay, in between the fast path and content inspection there is one more stage, but I will tell you what is that. Okay, so if the if the firewall is identifying the application in the fast path itself, the fourth stage, which is application identification stage. Okay, application identification. So if the firewall is identified, okay, if the firewall has matching signature for this traffic, the firewall will identify the application in the fast path itself, and this application identification stage will be skipped, and it is moving to the content inspection. But if the firewall doesn't have an signature, okay, if the firewall doesn't have a signature for this application, so it will be moving into an application identification stage. Okay, from fast path it will be moving to an application identification stage, because we don't have an signature for this particular Facebook. We don't have a signature. Might be the user has manually configured. Okay, so we can also configure an applications in the firewall that we'll be calling as an custom applications. Okay, so if the signature is not available here, the firewall will move into the application identification stage. In the application identification stage, the firewall will will verify if there is any custom application configured for this Facebook or not. Okay, so if the customer application, okay, we have configured an Facebook as a custom application, and it is going to identify that in the custom application. So if the firewall is identified that is a custom application, it is going to do an application override. Okay, so here in this case, what is application override means, so once the firewall is identifying the application, so this application is application in sense this is works on the L7, right? So it has to be process L7 inspection here. Okay, L7 inspection means it has to be do an all these things. Okay, threat detection, malwares. Okay, and if there are any antivirus for this particular okay, for that particular application, it has to be an L7 inspection, and then it has to be proceed further. Okay, otherwise it will be not okay. If any threats or antivirus are identified, it is going to drop the packet. So here if it is a custom application, this application override will it will verify if application override is configured or not. What application override will do means it will skip the L7 inspection. Okay, it will skip the L7 inspection, because we already know what type of application we are manually configuring, right? So we know how the application behaves, and we know what type of application it is. For that we don't need any L7 inspection. Okay, so that's where the application override will work to skip L7 inspection, and it will be proceeding further. Okay, if it is a firewall is identifying the application on its own, so the firewall has to know whether the application has any threats or whether the application has any antivirus are available. So it will be identifying the L7 inspection. Okay, that's where the content inspection will work. So it is going to skip the L7 inspection and proceeding further if it is an application identification. Okay, so it will, if it is moving application identification stage, it will be skipping the L7 inspection. And once it is done, application override is identified, so it is also doing an policy lookup here. So policy lookup will be happen here, because we also the firewall also want to know whether this custom application has to be allowed or not. So it will be verifying the policies, and if any policies are matching, it will verify the action whether it has to be allowed or block that particular application, whatever the custom application that we have created. So here in this case it will verifying the policy lookup whether it has to be allow or block, and in this case also it is going to do an policy lookup whether it has to be allow or block the custom application. So if it is allowed, it is moving further, okay, and if it is not allowed, if it is blocked, it will be blocking the session here, okay, it will not proceed further, it will be going to block the particular session here, okay. Next it is coming to the content inspection. So in the content inspection it is going to do an, okay, if it is this particular signature, okay, it is going to L7 inspection, going to do an threat, okay, detection, and vulnerability, it is going to identify if any vulnerabilities are identify, if there any vulnerabilities are there, or antivirus, or if any malwares are available. So it is going to do all these things in the content inspection, and once it is done, if it is not identifying anything, so it is going to again, so here this encrypted traffic, here the firewall did an decryption, right? So again it is going to re-encrypt the traffic, okay. So in the content inspection, so whatever the traffic is decrypted, so it is again going to encrypting the traffic, because so how we have received the traffic, so in the same way we have to send the traffic code. So if you are receiving the traffic as encrypted, so we are doing a decryption here to inspect the traffic, but whenever you are sending out, you have to send the traffic in the same way. So if you are receiving encrypted traffic, you have to send the encrypted traffic code for our okay, for our inspection, we are decrypting the traffic. So whenever you are sending the traffic code, we have to send the encrypted traffic again. So that is the reason. So it is re-encrypting the traffic, and it is proceeding further, which is our last stage, egress stage, okay. So in the egress stage, if all the, okay, if all the stages between ingress and egress stage are done, so it will be entering the egress stage. This is where the traffic is coming out, okay. So in the egress stage also, if it is an tunnel traffic, okay, if it is an tunnel traffic, so here we have seen, right, if it is a tunnel traffic, the firewall decrypted the traffic, right? So in the egress stage, the firewall decrypt the traffic here, but in the egress stage we are going to re-encrypt the traffic, okay, re-encrypt the tunnel traffic, okay. And also what it is going to do is, so it is also going to do an here one more policy lookup will happen, which is cost lookup, okay. It will do an cost lookup. Do anyone know about cost, quality of service? Anyone? Anyone know about quality of service?
It is allows you to monitor the traffic, whatever the
Monitor the traffic, okay, but that is half correct. So what is quality of service means, it will limit the bandwidth to the users, okay. Limit the bandwidth means, so let's take okay, you have a company, let's say assume you have a 3 users. So for these 3 users, for 1 month you have given 10 GB of data, okay. Okay, so for you, for the 3 users, for a month you have bought 10 GB of data, okay. If you are not doing anything, so if you directly assign the 10 GB of data for the 3 users, they will complete within a day, right? They will complete within a day or 2 or 3 days, this 10 GB of data will be completed. So to avoid that, what we can do means, we can, okay, use a firewall. What we can do means, we can apply a cost policy, okay. So let's assume this way. So you have a firewall, okay, and you have 3 users, and you have connected this to internet. From the internet you have bought a 10 GB of data, okay. So whenever you bought a 10 GB of data, if you are if you are not doing anything and you are directly assign 10 GB of data, they will complete in 2 or 3 days, the 10 GB of data completes, and rest 28 days they have to sit simply and they don't work anything, okay. That's not the case here. So this 10 GB of data you have to use effectively for 30 days, okay. For that you have to divide. So each user in a day they have to use only 100 MB or 200 MB, okay. Let's assume the user A needs 200 MB, so user B needs Okay, user A 100 MB, user B 200 MB, and also user C also it needs 200 MB per day. So after 100 MB, after their quota, okay, completes, so they don't want to use anything apart from the assigned quota. For that we are using a quality of service. So on the egress interface, that is the reason I am explaining that in the egress stage. So you are going to apply this in the egress interface, because it has connected our ISP is connected to our egress interface. That's where our traffic enters, right? Once the traffic receives on the egress interface, it is going to verify if any cause policy is applied. If policy is applied, what type of bandwidth we are providing for the user. So here in the cause policy we are applying, so for user A, so only 100 MB of data is required. So until 100 MB it is going to provide. After reaching its maximum quota, it is not going to provide anything. Okay, and in the same way for the user B we are providing 200 MB. So the user B will use the data until 200 MB, and after 200 MB they are not going to, okay, they will get an only the limited speed, but they are not going to access anything. Okay, after that, okay, the user C also will get data up to 200 MB. After that they will get an only a limited, okay, data only. Okay, likewise we are going to limit the bandwidth for the users. So if you are having a large, okay, if you are buying a large bandwidth from the ISP, so you have to limit the bandwidth for the users by using a cost. Okay, by using a quality of service we can limit the bandwidth to the users. Okay, that's where cost policy lookup will also happen at the egress stage if we have configured anything. If you are not configuring, so it will not verify anything. Okay, and after that the calls, after the policy lookup will happen, so the firewall will send the traffic out through the exit interface. Okay, exit interface means this interface. Okay, so after this the firewall, okay, the traffic will be reaching the internet. Okay, from the exit interface the firewall reaching the internet. So these are the stages that are involved whenever the traffic enter the firewall. And if the traffic enter the firewall, the traffic has to be come out, it has to be pass, or it has to be validate all these stages. Okay, ingress stage, slow path, fast path, application identification, content inspection, egress stage, all this has to be passed. If something is happened in between, the firewall will not send the traffic out, the firewall will drop the traffic. Okay, so any questions, any clarification that you need here? Any questions, guys?
దీనికి రిలేటెడ్ ఏదైనా మెటీరియల్ ఉందండి?
Related material in sense, we have, yeah, we have PPTs available in our okay, in our websites. You can go ahead and download those.
టోటల్ ఫ్లో.
Yes, total flow. So if I want to show you, I have a PPT here. So the same PPT we have, okay, uploaded in the website. So you can go ahead and okay, you can go ahead and download these PPTs. Okay, any questions or any clarification that you need here?
Sir, could you please send a screenshot of what you have reached up to now?
This one?
Yes,
Yes.
yes.
Top to bottom.
Yeah, I will save this. Okay, this is, I have did it in a Paint, I save this and I will share it. Okay.
సార్ ఐ హావ్ డౌట్.
Yeah, go ahead.
సార్ మీరు ఎప్పుడైతే సోర్స్ నుంచి డెస్టినేషన్ పోయే రూట్ చెప్పారు కదా, ఇంగ్లీష్ స్టేజ్ అని, ఫాస్ట్ స్లో స్టేజెస్, తర్వాత స్లో పాత్, ఫాస్ట్ పాత్, ఆ తర్వాత అప్లికేషన్ రిలేటెడ్, ఆ తర్వాత లాస్ట్ ఈగ్రెస్ చెప్పారు కదా, సర్వర్ ఐపీ నుంచి మనకి ఇన్ఫర్మేషన్ ప్యాకెట్ ఫ్లో రివర్స్ అయినప్పుడు కూడా సేమ్ అప్లికేబుల్ అవుతుందా సార్?
సేమ్ అప్లికేబుల్, దట్స్ వాట్. ఓకే, అక్కడ మనకి ఏమవుతుంది, మనకి ఎప్పుడైతే మన రివర్స్ ట్రాఫిక్ వచ్చినప్పుడు, సో వన్స్ ఇట్ ఈస్ రిసీవ్స్ హియర్, సో ఇట్ విల్ బి ఓకే, ఇట్ విల్ ఆల్సో డూ దిస్ థింగ్. ఓకే, extract the tuples. Okay, and with the tuples it will be going to identify the existing session or not. Okay, సో మనకు ఆల్రెడీ ట్రాఫిక్ ఫైర్వాల్ నుంచి వెళ్ళింది కాబట్టి అది ఎగ్జిస్టింగ్ ట్రాఫిక్ అవుతుంది. మనకి ఎప్పుడైతే రిటర్న్ ట్రాఫిక్ వచ్చిందంటే ఇక్కడ ఆల్రెడీ సెషన్ టేబుల్లో సెషన్ ఉంటుంది కాబట్టి దాన్ని మ్యాచ్ చేసుకొని డైరెక్ట్గా నీకు ఫాస్ట్ పాత్లోకి వెళ్ళిపోతుంది. ఫాస్ట్ పాత్లోకి వెళ్ళిన తర్వాత ఇట్ విల్ డూ ఆల్ దీస్ థింగ్స్ అగైన్.
Sir, but if I only want to place or filter on incoming traffic, so I don't care about outgoing traffic. So is there anything I can do?
Sorry, could you repeat that question once?
I just want to filter the incoming traffic rather than outgoing traffic because I don't want to waste my resource on whatever goes out from my side. I just want to filter what is coming. So what
Filter
is
in
in this
sense,
case?
see here, the firewall will log every session. Okay, the firewall will log every traffic, whatever the firewall receives. Okay, but if you want to
Mhm.
filter from the logs, you can filter. So if you want only particular session you want to filter, you can filter from the logs, but the firewall will not stop logging any session. Okay, whatever the traffic hit the firewall, it will definitely log the session.
Mhm.
Yeah.
So
Is that answer your question or
no. Actually, I just want to only ఓన్లీ ఇన్కమింగ్ ట్రాఫిక్ ని మాత్రం నేను ఫిల్టర్ చేయాలనుకుంటున్నాను. అవుట్ గోయింగ్ ట్రాఫిక్ ని నేను నా ఫైర్ వాల్ నుంచి ఐ డోంట్ వాంట్ టు మూవ్ ఇట్ త్రూ మై ఫైర్ వాల్. సో నేను ఇంకొక వేరే పాత్ ఎన్షూర్ చేద్దాం అనుకుంటున్నాను దానికి. అప్పుడు ఏంటి సినారియో?
I didn't understand your question. Could you elaborate the question once? Your filter in sense
So
what you are saying?
firewall is a very costly equipment, right?
Oh no.
So if it takes the incoming load and outgoing load, it will be more heavy burden for that firewall, right?
Mhm.
So I just want to cut it by the 50%, like only filtering the incoming traffic.
Mhm.
So if I want to do in that way, outgoing traffic ని ఈ ఫైర్వాల్ ద్వారా కాకుండా వేరే రూట్ లో ఎన్షూర్ చేసుకొని
Mhm.
ఐ ఓన్లీ ఎన్షూర్ ద ఫైర్వాల్ ఈజ్ ఓన్లీ కాన్ఫిగర్డ్ ఫర్ ఓన్లీ ఇన్కమింగ్ ట్రాఫిక్. దట్ ఈస్ వాట్ ఐఎమ్ ఆస్కింగ్.
No, that will not, we cannot do that. Okay, if that is the case, if incoming okay, if outgoing traffic is in one way and incoming traffic in other way, that will be calling as an asymmetric paths in the networking, right? So you can do, if you want you can do, but if you are receiving the outgoing traffic on the firewall, the same incoming traffic also you can see on the firewalls as well. So that you can do, using your other routers or you can do, but whatever the traffic receives on the firewall, whether it is an incoming outgoing, that will definitely be in the firewall. Any other questions?
If I use an URL, you said that in the English stage, it blocks the.
Hmm.
It doesn't contain the any URL in the English stage.
Mhm.
Above the first line.
This one.
So if I'm using my personal URL,
Hmm.
how does it work?
If it is a personal URL, the firewall has to be identify the URL first. Okay,
So
that,
what should I? Okay.
so
Yeah.
that we can learn in the URL filtering class.
Okay. Okay.
There will be a separate class for that URL category and filtering. So
Okay.
if it is a new URL or if it is a personal URL, how the firewall will
So,
classify that URL, we can learn in the URL filtering and
okay.
category.
Yeah.
Anything related to this topic? If not, we will be having session types. We'll complete in 5 to 10 minutes. So just let me know if you have any questions here on regarding this flow, packet flow.
Hello.
Yeah.
In the fast part, the fourth one.
Yes.
Actually, it's already encrypted. Then
Hmm.
why in the fifth session? What is the fifth one?
This one.
The content inspection.
Hmm.
Already it's encrypted. Why it's again encrypting in the content inspection? May I know how it is?
No. Here we have decrypted traffic. So
Okay,
we
the
are
fast part.
in the
Okay,
fast path, we have decrypted the traffic. So
okay,
after identifying the application, we are doing all the content inspections, and then we are again re-encrypting the traffic.
okay, okay. Thank you.
Yeah. So here, see here in the session types, we'll be having multiple sessions. The first one is an free. Okay. Next one is an init, open. Okay. Active, discard, closing, closed. Okay. So 1 2 3 4 5 6 7. Okay, here we'll be having session types. Okay, so 7 session types. So whenever there is no traffic and where the firewall doesn't receive any traffic on the firewall, all the sessions. Okay, so every firewall will be supporting some type of session. Okay, in this case we'll be having PAVM firewall. We are using PAVM firewall where it supports maximum up to 2 lakh sessions. Okay, so whenever there is no traffic, all the sessions will be in the free state, and we'll be calling as an free bucket. All the sessions will be in the free bucket, and that's where you can see that is as an free session whenever the firewall receives the traffic. Okay, so whenever the firewall receives, let's suppose whenever the firewall receives the first packet, or whenever firewall receives the this traffic from the free bucket, one of the session will be okay allocated, and it will be moving from free state to init state. So this is when the firewall receives the traffic, and the firewall identified the first packet in the traffic. Okay, so if the first packet, let's assume you are doing an TCP, okay, TCP connection. So in the TCP connection, if the traffic is received on the firewall, it will moving from free to init state. So in the init state, if the firewall is identified the first packet, okay, which is our SYN packet, if the firewall identified SYN packet in the init state, so from init state it will moving to the open session. So in the open session, so all the SYNAC acknowledgement will be done, and after that it will be exchanging data, right? So from open state it is going to moving to the active state. So in the active state, what it will do means the firewall will check the policies, and if the policy action is set to be allow, the firewall will be okay, you can see the session type as an active. Okay, here we have mentioned about the type, right? So in this type you can see the session type as an active. If the type as an active, the firewall is allowing the traffic. Okay, and if okay, after the open state, if the firewall is blocking the traffic, okay, if the firewall do a policy lookup, and in the policy the action is set to be blocked, okay, you can see. So from open to, it will be moving to the discard state. Okay, whenever the traffic is set to be blocked, you can see the discard. Whenever the traffic is set to be allow, you can see the active state. Okay, so in the type you can see the block whenever the traffic is set to okay, sorry, not block, discard. Okay, type as and discard to whenever you have mentioned the policy. Okay, and whenever you have mentioned the policy to set the traffic as block, means deny a drop, and everything is done, and my okay, my data flow is done and everything is completed now. So here we are sending an fin packet. Okay, so if the firewall get any fin packet from any one of the whether from the client or the server, it is moving from okay, if any of the state to, it will move into the closing state. So in the closing state, the firewall will not close the session completely, so it will get a fin from one side, but still, so on that side the session is still open. So it is, we can say it as half close, right? Half close or half open. Okay, so the session is said to be half open, still the firewall will monitoring the session. Okay, monitoring in the sense, whatever we have sent the fin, if the this client, okay, we have received an fin from the client, and after some time the client has some data to send. Okay, it will again send the data, right? At that time it will be again moving into the active state or discard state. Okay, based upon the act of traffic we are sending, and based upon the okay policies, it is going to the active or discard state. Okay, that's the where the closing state will work. So if the everything is done and we have received fin from both sides, okay, from the client also you have received fin, and from the server also you have received the fin, and the firewall will be moving to the closed state, and once it is done, so once the session is closed, again it move to the free state, and whatever the session that we have taken from the free bucket, it will again move into the free bucket again. Okay, from 2 lakh session we have taken one session. Okay, and we have completed all this, and again we have returned that session to the free bucket. Okay, and the firewall, okay, whatever the firewall that you are using, that will be having some limit for the sessions. Okay, for PAVM you can see, it will be going to support 2 lakh session. So once the 2 lakh session completes, whatever the next traffic comes, it will not allocate any session. Okay, because there is no free session available, so it will not allocate until unless one session is freed from the from your session table. Okay, these are the 7 type of type 7 session types available. In this we will be having stable sessions and transition sessions. Okay, transition, stable. Okay, what are transition means? It is quickly moving from one state to another state. Okay, we cannot see that states. Okay, what are those state means? Free, open, closing, closed. Okay, all these 4 sessions are transition states. It will be quickly moving from one state to another state. Okay, it will moving from free to init. So init to open. Okay, open will not see, it will quickly move into the active state. Okay, so what are stable statements? The stable states are those which we can see. Okay, you can see in the session table. Init you can see, active you can see, and discard you can see in the session table. Okay, where we have mentioned as a type, right? So in this type you can see init, active, and discard. Other than that we cannot see all the transition states. Okay, so these are the type of sessions that we have in the Palo Alto. All will be considered. Okay, some are considered as a transition, some are considered as a stable. Transition state we cannot see, stable states only we can see. Okay, so any question or any doubts here? Any questions, guys? So this ends our today's class. Okay, so this will also ends our basic firewall fundamentals. So tomorrow, so everyone come up with the lab tomorrow. Okay, so we are going to do our first lab. Okay, so tomorrow we'll see how the, I will show you how the firewall looks, what are the things that are available in the firewall, and what are the things needed, basic things needed to configure in the firewalls. Okay, so just I already shared all the images who are sent the mail. So if still anyone has didn't send email to me, so just share your email ID, so I will share the image, so that you can deploy that. So whoever received the all the images, please try to set up the lab today. So tomorrow we are going to do our first lab for this course. Okay, and you can see what are the things that are required, or basic things required to configure in the firewall. Okay, so any questions or any clarifications that you need here in this session?
No, at least we have to watch videos couple of times.
Yeah, these are all I think this terminology is new for you, right? So it will take some time, but once you are going through this, you will be understand. So please be watch this video again, so that you will be aware, or you will understand, or you will be remembering the key terms. Okay,
Yeah.
okay guys, if you don't have any questions, we can wind up this session here. So please do join same time tomorrow, so we'll going to do an hour lab. So meanwhile, if you have any questions also, you can let me know. And if you are stuck anywhere in setting up a lab, so you can just ping me in WhatsApp. Okay, I will respond to you and try to resolve your questions, your issues. Okay,
Okay.
yeah.
సార్ ఈ స్క్రీన్ షాట్స్ క్యాప్చర్ చేసి గ్రూప్ లో పెట్టండి.
Oh yeah, I will save this paint file and I will share it with you. Okay, yeah. Okay guys, thanks for joining the session, and have a good day. See you tomorrow at same time. Bye.